So homework 4 is about chapter 16, and then I'm going to start chapter 17. After break, we'll do homework 5, and that will be on chapter 17. Okay, so in this class, we talked about conditional probability. We did a good number of examples, and I want to make up 1 or 2 more examples and then move on. So you guys did a lot of stuff. Oh, okay, cool. We got to the very last table. And then, like I said, I'll probably make up 1 more thing after. Okay. We have SRTW on the side. And start. Here is P, Q, and a total. I put 40, 20, 70, 20. 10, 50, 10, 30. So that would be 50 total right there. 70, 80, 50. Let's see, that's 180, 90, 200, and then we've got 5 more, so 250. Okay, we'll double check though after we get this part. 60, 70, 80, 90, 100. 60, and that's, let's see, 130, 50, 150. 250 that way if we get this total on the bottom. All right, now let's ask questions like find the probability of T.
What was the variable you said we're finding?
T.
Thank you.
Okay, we will find the outcomes for T, which is on this side here, 80, and then divide by the total number of outcomes. Let's see, I would probably, I mean, that's correct, but I'd probably get like a decimal answer. Let's see, 80 divided by 250 is 0.32. let's find the probability of W and Q. Let's call this part B. This A is this B. All right, so unfortunately the table takes up a lot of the whiteboard. So hopefully get this part done. W intersect Q. We'll find W and Q. So you want this number here. 30, and then divide by the total, 250. So it's the place where you intersect W and Q and get that part where they overlap. Add the total. Okay, let's find the probability of R and Q. Okay, let's work on it for a moment. We're looking at R and then intersected with Q. So this part here. We've already kind of highlighted Q, but we'll copy it again. Okay, now we're here. R intersects Q, and there's 50 outcomes there. To get the probability, take 50 out of the total. All right, and as far as I'm concerned, I wouldn't mark this wrong, but we can easily simplify this. So if you take a moment, it's just divide both, or let's factor the numerator and denominator. That's better. 5 times 10, 25 times 10. Okay. 10 over 10 reduces to 1. So 5 over 25. 5 over 5 times 5. Okay. 5 over 5 reduces to 1. So what's left in the top is a 1. 1/5 is the answer. Let's do... Yeah, if I had more space, we'd put that right there. But you end up getting probability of R intersect Q equal to 1/5. Okay, now let's try conditional probability. Oh, and also note from the chat, we're not doing only last week's material. We are going to start something, at least one thing that's new after another example or so. Okay, let's do probability of R given Q. All right, so it's probability of R intersect Q divided by the probability of Q. Okay, we got this probability. R intersects Q is 50 over 250. This probability in the denominator, probability of Q is, where are we? 100 out of 250. Okay. 50 over 250, multiply by 250 over 100. So that 250 over 250 reduces to 1. 50 over 100 is left over. Which is like 1/2. It's okay. I think we should try like 2 more of these. Find the probability of P given S. That looks kind of weird. That's okay. So this is a P for probability, and that's a P for like the category P.
Professor, just to confirm that says 0.590 the past, right?
Yeah.
Relative R given Q.
Yeah. Yes. Okay. Let's do this. Probability of P given S. It's probability of P intersect S. And then divide by the probability of S. Okay, probability for P intersect S. Find P, and it intersects with S right here. So P S 40. Now the probability for S will be this number here, 50 out of 250. Okay. Hopefully you've had a chance to write this table down, but I have it in my notes. And if you don't have it written down, I'll just kind of pull from my picture. Okay, top fraction, multiply by the reciprocal of the bottom fraction. Okay, just 250 over 250 is 1. So we could do like 4 times 10 and 5 times 10. Here's another one of these guys. one more. Let's do it. The probability of Q given W. And just remember that's going to mean given in this formula or in this notation. The separate bar means given. Okay, probability Q given W is probability of Q and W divided by probability for W. Okay, so check your table if you copied it down. Find where Q intersects W, and I have 30. So the probability is 30 over 250. Also, please let me know if you see any mistakes or anything like that. Now, probability for W is 50 out of 250. And work this to look more simplified. Okay, so this over this is 1. Actually, I'm going to go over here. Okay, 30, 3 times 10. 55 times 10. And then we have 10 over 10 is 1. And 3/5. Okay, for the last example, I will create a small sample space and we'll make some easy sets and do one conditional probability and move on. Okay, let's just do like 1 through 7.
Is this still on conditional probabilities or property? I wrote property, but probably probability.
Yeah, it's still conditional probability, and it's the last thing we're doing for chapter 16.
Cool.
Let's put A equal to the set that contains 3, 6, 7. B will contain, let's do 4, 5, 7. Let's do the Venn diagram. Sets A and B. They both share the number 7, which means they are not disjoint. Okay, moving on. 4, 5, and 3, 6. Need 1, 2, 3, 4, 5, 6, 7. Let's do the probability of B given A. So we'll talk about it first, but then we'll write down what the formula is. So you know A has occurred. You're given that A happened already. So you restrict the sample space down to A and then find how many times B can happen. So A is the event that's already happened. Everything else doesn't matter anymore. And now elements from B, that number 7, happens 1 time out of those 3. So the answer will be 1 out of 3. But we'll get there with that formula. So take probability of B given A to equal probability B intersect A. Divided by the probability of whatever's in that second spot. So probability of A. Okay. B intersect A. That's the set that contains 7, which is just one element out of all 7. Okay, divide by the probability of A, which contains 3 elements. So its probability is 3/7. Okay, 1 over 7. 7 over 3. Okay, 7 over 7 reduces to 1. And there's a 1/3 left over. That's that. So there's a little bit of this on your homework, conditional probability. It will probably be on the exam. So
Could you repeat that you said just about 10 seconds ago? It kind of got glitchy.
okay. Just like that's the end. And there is conditional probability in the homework. I may put it on the exam. Maybe not. I don't know. We'll see. Okay, so excuse me. You know what? We won't worry about it for the test. This time it will not be on the test. And I'll write it down. I'll remind myself. It's interesting, but you don't have to stress about it. Okay, I want to start chapter 17. There's like 2 definitions to do and then a handful of examples, and that's the plan for today. So again, I'm doing just a little bit from chapter 17. This will also be on exam 2. Just the parts that we cover together. The normal curve. We have kind of looked at this before when we talked about distributions that had that were normal. They were bell-shaped. I think I might save that for later. For now, we want to define random variable and then the mean of a random variable. Numerical measure of each outcome in the sample space of an experiment. I'm just going to end it there. Ooh. Yes. Oh. Man. I think sometimes I'll write RV for random variable. So if you ever see RV, it means random variable. So the variable that we're using to measure outcomes from the sample space, to measure the chance that each outcome will occur. Okay. A little bit more just to set up. We use capital letters for the random variable. In this class, we'll mostly use X. But you know what? Just in case we switch it up, let's keep it open. Capital letters. Okay, and then we'll use lowercase letters. Let's see. For specific values assumed by the random variable.
I could be reading it wrong, Professor. The we or you use
Let's see.
for capital letter.
Capital letters for the random variable. Oh, I see.
For some reason, I thought it said we, but it makes more sense if it says use. So.
Oh, okay. Use. Oh, see. Yes. You can also say like we use, but anyway. Okay. Mostly I'll be doing this part, but if you're like, why is it capital? Why is it lowercase? It's just for certain situations where you want it to be random, so capital, and lowercase is specific, like an actual number. So use lowercase letters. For specific. Random variable. last thing, and then we can do examples, is the mean of a random variable. Right, it's the Greek letter mu. So it looks like U with an extra hook on the front. So you go like this. I think it's like mu. There you go. Okay, you could put U, it's fine, but we're gonna try using this symbol for the mean, and it equals the sum of all of your x values times their probabilities. So add all x times p of x. Some people put a little x here, which means like for every value of x, put that number in here, take x times p of x, but I'll probably leave that off. Okay, so we're just practicing this today. Let's see how many examples we can do.
Is there anything in between sigma x and p of x? Is that like a multiplication?
Yeah.
Okay.
Okay, first one. X, B, A, random. Right. X, P of X. All right, our values of X are going to be 2, 3, 4. Okay, probability for 2 is 1/6. And then 2/6 and 3/6. Okay, find the mean of X. And actually, I wanted to put this up earlier, but I often like when they put the mean and then they put the variable as a subscript. So the mean of X, I'll probably write as like mu sub X. So capital X in the subscript. Okay, the mean of X, mu sub X, is to take all X and multiply by P of X and add them together. All right, I start this over again. Our X values are 2, 3, 4. I'm going to start with 2 times probability of 2. add in this part. 3 multiplied with probability for 3. And 4 multiplied probability for 4. Okay, then we plug in the probabilities. 2 times this probability, 2 times 1/6. 3 times 2/6. Add 4. 4 times 3/6. I will just work this over here. And we have 2/6 plus 6/6. And 12/6. I got 20 out of 6. And I guess just a little simplified. 2, 3. We could go even further. I'm going to put this in my calculator. 10 divided by 3 is, 3.3 with a bar. I like this way. Okay, so that is the mean for x. Okay. Let x be a random variable. New example. With the following probability distribution. Okay, and I'm going to draw the table up here. Okay, so we still have x. Probabilities for x. This time, x is equal to -2, 0, and 2. And probabilities are 0.1, 0.7, 0.2.
Just to confirm, the first x is -2, not positive. It's a -2, right?
It's negative, yeah. It's fine. Okay, find the mean of x. Okay, the mean of x is use of x equal to the sum of x times p of x. This time it's -2 times probability for -2. All right, add 0 times probability of 0. And add 2 times probability of 2. -2 times 0.1. Well, this is going to be 0, but I'll put in what you would have. It would be 0 times 0.7. And then add 2 times 0.2. Okay. -0.2 plus 0 plus 0.4. So I have this together as 0. Let's do one more, and then we'll be good for now. Do extra examples next time. Okay, I'm going to stick with x as our variable. So, example, we still have x. Let x be a random variable. Okay, again, we will draw the distribution up here. X over P of X. All right. Variable has values of 0, 1, 2. We've got 0.3 as the first probability. Then 0.4. 0.3 again. That's it. Of X. All right. There's a question about fractions or decimals. I don't mind either way, as long as it's a correct answer. You could have it fraction form, decimal form. It's nice if your answer is fully simplified, but I'm not going to be picky about that. And, on this test. Okay, find the mean of x, which is mu sub x. We take the sum of x times p of x. And that's going to be, I mean, if you're getting used to this now, 0 times 0.3 plus 1 times 0.4 plus 2 times 0.3. But still, just want to show where this all comes from. 0 with probability 0. 1 times probability 1. Add 2 with probability 2. 0 times 0.3. 1 times 0.4. Add 2 times 0.3. All right. So that's 0 plus 0.4. And plus 0.6. So I got 1 total. Okay, I think that's good for now. So we'll save other samples for next time. And yeah, we want to get talking about the normal curve and then probabilities under the normal curve. And that'll be kind of the goal for chapter 17.